Okay, this, guys, is the second time through doing this because I'm using my cell phone as my document camera and I did not pin it. So I can see this, and the hope would be that you could see this. But when I did it the last time, it was 15 minutes of you looking at me talking. That was great. Welcome to my quarantine. Glad to have you all here. Right now, I'm going to be using this opportunity to go through and show you guys the review worksheet and how to do everything from on there. And I'll try to go a little faster this time. I talked a little bit slowly the last time, and that was not the greatest. So this will be up on Google Classroom for you, and I believe that this will also be played in your class for you. So for these first two, we're going to be going back and forth between exponential and log form. Um, just as a reminder, anytime that we have something in exponential form, we've got a base raised to an exponent that is equal to an answer. When we change that to logarithmic form, essentially we're just moving this stuff around. So when we do that, we're basically saying, okay, you put the base down here, then we've got the answer right there, and it is equal to the exponent. So that is the base answer exponent version of that. So essentially we're just moving things around. So here, when we've got this written as 7 to the 4th power equals 2,401, what we're going to be doing is writing that in log form. So first you write the word log. 7 is my base, so I'm going to put that down here. And then 2,401 is my answer. So I'm going to put that there. And that is going to equal to the exponent, which is here. So that's my base, my answer, and my exponent. Now, that's the way that you've got to do it. If you do the order in a different way, then that's not going to be correct. So I just want to make sure that you're on the same page with that. Going in the other direction, the nice thing is that if we remember what our base, answer, and exponent are, we can use those to write them out. Our base is 4, so we write that as our base. Our answer is 1,024, so 1024. And the exponent in this case is 5. So we write it up like that. So 4 to the 5th power is equal to 1,024. And that's how you do stuff like that. And it just goes back and forth. And you had some of these in that previous quiz as well. So you should be in pretty decent shape, but that's the way that we do these problems. For problem 3, this is where we're evaluating logarithmic expressions. For all of these, your first step is going to be to put them in exponential form. So I'm going to do that kind of across the board for all of them first. This is going to be 2 to the x is equal to 16. This one, 5 is my base, x is my exponent, 125 is my answer. It's the same general idea with the fraction, you just have to write it here. So 6 to the x equals 1 over 36. Now with these, you are going to have a chart that you can go down to figure out sort of what the powers are, because that's our goal here, is to look at what this is equal to, get the bases the same, and then set them equal. So 16, you need to write it with a 2 base. 125, I need to write it with a 5 base. And that 36, I'm going to need to write it with a 6 base. Now, that's on the bottom, so we are going to have to work with that in a minute, but it gives us the general idea. When we look at our chart, when we find 16, that is actually 2 to the 4th power. 5 is in fact, or 125 is in fact 5 to the 3rd power. And 36 is 6 to the 2nd power. So the reason I did all of those in the same thing is because that's the same process. You're going through finding out where this number falls on your chart, and then where it kind of fits within this. And when I write the equation, if I have 2 to the x equals 2 to the 4th, as long as your bases are the same, we can say that the exponents are equal. So in this case, this means that x is equal to 4. Here, if I do 5 to the x is equal to 5 to the 3rd, the bases are equal. So I know that x is going to equal 3. And so problems like those, they're pretty straightforward and pretty easy. The one with the fraction only involves one additional step, because as you can tell, 6 to the x and 1 over 6 squared, I don't have the same base yet. I do have a 6, but we have to do something with that. What we remember from before is that if I have a fraction with something with an exponent on the bottom, I can write it with a negative exponent. So 1 over x to the n is equal to x to the negative n. So here, 1 over 6 to the 2nd is going to equal 6 to the negative 2nd power. So now when I rewrite it, 6 to the x equals 6 to the negative 2nd, what it means is that I have the same base. I've got the exponents equal, so I can say that x is equal to negative 2. That gives us our answer. Again, these are not difficult. They're just things that you've got to kind of work through. So now we move on to expanding and condensing our logarithms. And this is where we're going to be using the laws of logs. I'm going to probably put those laws next to here so you can see this. In this case, when we're talking about expanding or contracting, we look at what the operation is that combines them. And so what we found is that if I have any log of two things being multiplied together, I can split that into two separate logs, has the same base, and multiplication turns into addition. So log base a of x times y is log base a of x plus log base a of y. So basically multiplication becomes addition. So here, when I've got this as multiplication, I know I'm going to be writing that as an addition because that's what the change is. Two separate logs, same base. And then I just take the first thing here and the second thing here, and that's going to give me the answer for what I have to do for expanding it. You're taking one, splitting it out into two. And then sometimes you split them into more. Excuse me. Damn you, COVID. Okay. In the second one, we have a fraction here and we have some exponents. So I've got to deal with both different rules. One of them is that if I have a log with a fraction, it turns into subtraction. I didn't leave myself a lot of space, so I'll do my best. Log base a of x minus log base a of y. So the top one is always first. Your denominator is always second with subtraction. So fraction and subtraction go together. And then if I have something that has an exponent, and we'll just say x to the nth power, anytime that I have an exponent here, I can bring that exponent down to the front as a multiplier, n times log base a of x. And so with this, because I've got both exponents and fractions, got to deal with both rules. So I'm going to take them one piece at a time. The main connector here is the division. So we're going to be using this first rule. I'm going to be writing log base 5 of d to the 6th, because that's the top one, minus log base 5 of e to the 3rd. So I basically just separated the fraction into subtraction, just like here, fraction into subtraction. Now with both of these, because I have exponents, I'm going to have to bring those exponents down to the front as multipliers. So this will be 6 log base 5 of d minus 3 log base 5 of e. And that'll give me my answer. I know I'm done because when I look at the logs, I've only got one single thing that I'm taking the log of. That lets me kind of take me through the end of this part of it. Now, going in the other direction, if I've got something that's already expanded like I have here, I've got to put them together. Now, remember with this, we've got to do them basically two at a time. But before I do anything else, if I have a multiplier out front, all of those are going to have to go up as multipliers, or excuse me, as exponents. So log base 3 of x to the 5th plus log base 3 of y minus log base 3 of z to the 2nd power. Pause for a minute, take a drink. Okay, so the next thing that you want to do, now that we don't have any multipliers out in the front, is to combine these things two at a time. So I'm going to take these two first. Addition combines as multiplication. So we'll have one log base 3. X to the 5th is first. Y is second. And so we've got that part combined. And this one we haven't done anything with. So I'm going to put that over here. Now, I've got subtraction here. So when I combine them, I'm probably going to use some space off to the side. I don't think this is going to be my best. When I combine these, I will be combining them with a fraction. And still the same log base 3. Whatever I had before the subtraction, that goes on the top. So x to the 5th times y. Whatever I had after that fraction goes on the bottom. Z to the 2nd. So log base 3 of x to the 5th times y over z squared. That is our answer for this one. Okay, and that takes us through the first page. Now, everything that we're doing on the second page and moving through the rest of it is going to involve using a calculator. So I actually didn't have mine. So I happened to find in the basement my daughter's old middle school calculator. All you need is a log button. And in fact, your phones have log buttons on them, but the calculators that you're going to be getting when you take the test are also going to have the button on them. So I just want to make sure that you know you don't just have to do this from the calculator that you get in class. Now, you'll notice for both of these equations, and every time I put my hand out there, it focuses differently, but you'll notice that I have an x in the exponent for both of those. Anytime you have that, your default should be to use logs to solve it. Take the log of both sides of the equation. It will be the easiest way to find the answer. So log of 6 to the x equals log of 100. Now you'll notice I have not written a base here because I'm using the common log, the log that we have our button on the calculator for. And the reason why I do that, and the reason why I take the log of both sides here, is because my goal is to find this x. We just found on that page before is that anytime that I have an exponent, I can bring that down to the front as a multiplier which means if I take the x from the exponent to the front, I can now just deal with these things as numbers and not have to worry about anything else. So if I have x times log 6 is equal to log 100, both of these are numbers that I can get in my calculator and find out what the answer is. Because this is just a number times x, if I divide both sides by that log of 6, I'm basically canceling this out and leaving my x behind to get the answer. So x is going to equal log of 100 divided by log of 6. And this is something I can plug into the calculator. Now, this is calculator ready. This is what I would plug it in right before we get started. So as I start this, clear everything out. If I do log of 100, close parentheses, divided by log of 6, should be able to give me the answer. And in this case, 2.57019 and the rest. I'm only doing the first 3. So since it's 0, 1, I'm just going to say that this is 2.57. And that is my answer for x here. And that's the reason why we use our calculator to do this, because I'd never be able to figure that out by trial and error. Now, this problem here, same exact thing. Like we still have an x in the exponent. So we're going to take the log of both sides. There's just one step that you're going to follow first before we get to the solution. It's a little bit more complicated than what we did there. And it's actually not too difficult. We just have to kind of get to it. So our first thing again, log of both sides, log of 4 to the x plus 1 is equal to log of 289. Now, again, just like before, I'm going to take that exponent, bring it down. But because it's in parentheses here, I'm going to leave it in parentheses. X plus 1 times log 4 equals log of 289. Now, when you see parentheses, oftentimes you are compelled to distribute. And I'm going to tell you right now, you don't want to do that because this right here is just a number that's being multiplied by this simple thing in the parentheses. If I move this over to the other side, I can do it in one fell swoop just by dividing. If I divide by log 4 right now on both sides, this will cancel out, and I'm just going to be left with that x plus 1, which is a lot easier than all the crap I would get if I distributed it. That's going to give me log of 289 over log of 4. Now, if you wanted to plug that in your calculator and get an answer right now, you totally can. I still need to move that 1 over to the other side. And so I got to subtract it here, and I've got to subtract it here. So this will cancel. And I'm going to get that x is equal to, now, I need you to understand, these two are not in any way like terms. I cannot combine them. I'm just going to write them next to each other. So log of 289 over log of 4. And I got a minus 1 here at the end. So I'm going to get an answer with this. Something point something something. And then I'm going to take 1 off of it. So that just basically the number in front of the decimal is going to go away. So like right now, I'll even type that in. Log of 289 divided by log 4. That is going to give me 4.087. And then if I subtract 1 from that, it's just going to be 3.087 as my answer for x, because it took 1 away from what we see right here. Now, I could do that with a minus 1, gets the same answer that I need, but I just wanted to make sure that you could see it. You can totally type the entire thing in the calculator and just equals, or you can take it off in that step. Bless you. Okay, so now we're going to talk about these next 2 problems. Here, explaining why x in the equation is equal to a number between 4 and 5, there's a couple things that I can do. Regardless, I need to put this in exponential form to be able to kind of work with it. So the first thing that I'm going to do is write this as 2 to the x is equal to 30. Now, just like these 2 problems up here, I can totally take this and do the log of both sides and solve it. And I'll show you that in a minute. But there's also another reason why that it would be between 4 and 5. Because if you think about it, if I'm plugging it in here, one thing that I could say is, well, 2 to the 4th is equal to 16. 2 to the 5th is equal to 32. Those are just answers that are true. So if I plug in 4 and 5 here, that's 16 and 32. So clearly 30 is between 16 and 32. Well, let's write it the correct way. So x is between 4 and 5, because that's what those 2 exponents are going to be. This is a way to do it without using logs. Now, we can find the exact answer right here. So if I take this and just solve it, you bring the x down to the front. X log 2 equals log 30. Divide them both by log 2. X is going to equal log 30 over log 2. Let's plug it in here. Log 30 divided by log 2. Should we get that back here? 4.91. So 4.91 is between 4 and 5. So the exact answer is absolutely between 4 and 5. So it's up to you in terms of which way you'd like to do it. This is the way that is a little bit more general, and this is one that is more specific. They're both correct, and either one would be accepted. Now, change in base formula is actually not something we had a chance to go over. You had the video for this on Wednesday, or excuse me, on Tuesday, but it's essentially when you have something here where the base is not 10, you can basically take it. So I'll give you the general formula, log base A of B. I can plug it into the calculator and say log of the big over log of the little is going to be the answer. So if I wanted to write this and just use the formula, this would be log of 222 divided by log of 7. Just using the formula to figure out what the equation is. And I'll use my calculator to figure that out. Log of 222 divided by log of 7. And I'm going to get 2.776. Okay, so we've answered the question. Another way you could do it if you wanted to is if you want to write this as an exponential. If we did log base 7, 222 is equal to x. If I wrote that as 7 to the x power equals 222, I could solve this just like I solved everything else on this page by taking the log of both sides. Could bring that x down, x log 7 equals log of 222. And then if I divide both sides by log 7, what you'll notice is that x equals log of 222 over log of 7, which is literally exactly the same thing that I had as the formula. So you guys can do this however you'd like to. For me, the formula is the fastest, but I know that sometimes people forget. So if you want to, and all else fails, you can put it in the exponential form and just solve, and that should be fine. Now, I am hoping that this video worked. So I'm going to stop the recording now, and I'm going to look at it. And if it worked, that's great. And if it didn't, you're not getting a video because I'm not recording this thing 3 times. All right, guys, good luck and stay away from COVID.